Good morning, everybody. The new era has begun in our residential school society. This is the Super Students lecture series which have been started for the benefit of our students. And from today onwards, continuously we are going to have the lectures of the students who have been selected by you. And this is a Earn While You Learn program. The student also earns while she teaches here. We will be paying her 1,000 rupees for this program what she is going to give today. And we have here Miss Pallavi from Mahindra Hill School. She is studying intermediate second year MPC and she will give you a lecture on sound and waves. Thank you.
Hello my dear friends. Today I am very happy to be in front of you. And actually I want to ask you a question is that, can you guess what is there after one day as special? Yes, you are right. We are going to celebrate Diwali. At Diwali, by listening that name, what's the first thing that comes to your mind? Yes, the delightful sounds and the crackling sounds and the delightful lights with different colors. Yes, we'll see all this. So now we are going to discuss about the sound of crackers. Let's see. Sound of crackers. Actually, my topic is to teach about sound, but to grab your attention, I am saying like that to sound of crackers. Let's see. Now you have to watch some of the videos and pictures. Yes, now you have observed many of the musical sounds from different musical instruments. Let's see, from that most of the information comes to us in the form of waves. In the form of wave motion, the sounds are reaching our ears and the light to our eyes and the electromagnetic waves to our radios, televisions and mobile phones, etc. Like that, let's see what is a wave. Let's see what is a wave. So before going to wave, let me tell you the basic things so that you can understand the topic easily. Firstly, about medium. Let's see. What is a medium? Medium is nothing but the matter which allows something to pass through it. Get it? Medium is nothing but matter which allows something to pass through it. And the next one is oscillation. Oscillation. Let's see oscillation. Let us assume that this is a particle and if it moves somewhat little bit forward and backward and later it comes to its original position. The forward movement is called to and the next backward movement is called fro. The to and fro motion of a particle about its mean position, that is called oscillation. Let's see, to and fro motion of a particle about its mean position is called oscillation, and we can also call it as a vibration. Get it? We can also call it as vibration. And let's see what is frequency. These are the basic things, so that going on topic you will understand easily. Frequency. Frequency means number of oscillations per second. Per second. Number of oscillations took place in 1 second. Let's see, suppose there is a musical instrument. Let's see, this is the tuning fork. If I strike this tuning fork, these are the oscillations of this tuning fork, and here it is written 512. The oscillations, the frequency of this tuning fork is 512. So that we can guess that number of oscillations per second, and the units are hertz. We'll measure the frequency in hertz. Now let's see what is a wave. Wave, which is the main topic. Wave. Listen to me carefully. Wave, it is a periodic disturbance in the medium which carries the energy from one place to the another place. Get it? A wave is a disturbance in the medium which carries the energy from one point to the another point. And the next one is wave motion. Wave motion. Wave motion is nothing but actually the movement of a wave, but it can be defined as the periodic disturbance in the medium due to the repeated periodic motion of the particles of the medium. Get it? Get it, friends? See, listen. The periodic disturbance in the medium due to the repeated periodic motion of the particles of the medium, that is called wave motion. And let's see after that, here you can see that here you have to watch a video. See, now here you can see a video. When a water drop falls in a pond of water, then the energy from the water drop is transferred to the molecules of the water, and the molecules of the water vibrate up and down, and you can see the round ripples around the point where the striking of take place. Let's see, that is called waves. That is called waves. We can see that waves. These are nothing but the ripples. The water waves which are present, which are formed on the water surface, they are called ripples. Let's see what is a sound. So before going to sound, I want to tell you one thing. In the childhood, I think you might have experienced some of the paper boats, preparing paper boats and placing over the water surface in the raining season, and you will keep enjoying them, no? Like that, you observe why the boat travels on the surface? That is due to the formation of the wave. When the wave is formed on a particular surface, then the object on that vibrates. Let's see. Now let's see what is a sound. So before going to that, I'll tell you an energizer. Let's see, energizer. Once place your fingers over your throat while speaking. I said while speaking, place your fingers over your throat. Then you can observe some of the vibrations, and here you can notice that the vibrations are occurred by the vocal cords. Vocal cords are the source of the sound in a human body. Get it? And here you can notice that when the vocal cord is vibrated, the sound is produced. From this you can notice that every vibrating body produces sound. Every vibrating body produces sound. Let's see what is a sound. Let's see what's the sound. Sound is a form of energy which propagates in the form of longitudinal waves, which carries the energy from one place to another and carries the sensation of hearing on reaching the ear. This is called sound. And all the sounds are not audible. Let's see, all the sounds are not audible because basing on the frequencies, the sounds are categorized into 3 types. Get it? All the sounds are not audible. This is the noted point. Let's see. All the sounds are not audible. This is very noted point. Let's see. Basing on the frequencies, the sounds are divided into 3 types. Basing on what? Yes, the children over there, you are very good. Basing on the frequencies. The sounds are divided into what? 3 types. One is infrasonic, audible, and the third one is ultrasonic. Infrasonic waves. Let's see infrasonic waves. Previously I said that these waves are depends on the frequencies. That means the sound waves with the frequencies less than 20 hertz. Less than 20 hertz are known as infrasonic. Less than 20 hertz. Less than 20 hertz are known as infrasonic waves. These infrasonic waves, you can see that the examples of earthquakes and volcanoes are some of the examples of infrasonic waves. And next come to audible sounds. Audible sounds, by hearing the name we can notice that the sounds which can be heard by a common man. Let's see the frequencies. The sound waves with the frequencies in between 20 hertz to 20,000 hertz are known as audible sounds. These are called as audible sound because which a common man can hear. And we all know that the safest and healthiest sounds are called musical sounds. These musical sounds are come under audible sounds because the frequencies are like this. Audible sounds are between 20 to 20,000 hertz. And the musical sounds are from 30 hertz to 5,000 hertz. That is why we can hear the very types of music. And the next one is ultrasonic. Ultrasonics are the sound waves with the frequencies greater than 20,000 hertz. Let's see, greater than 20,000 hertz. Greater than 20,000 hertz are known as ultrasonic sounds. These ultrasonic sounds cannot be heard, but still it can create an acute pain in the eardrum due to the great penetration power. And ultrasonic sound waves have great penetration power when compared to these 3. And let's see, ultrasonic sound waves used to measure the depth of the sea. And you all know that that's sonar. Sonar. Sound navigation and ranging, which is used to measure the depth of the oceans. This works on the principle by using the ultrasonic sound waves. And you all know that radar. Radio detection and ranging. This was invented by the scientist on the basis of sonar. And we all know that we will use the electromagnetic waves in the radar system, and whereas in sonar system we will use ultrasonic sound waves. But you believe it or not, these two are invented just because of bats. Because bats are the animals, they can detect the ultrasonic sound waves up to 1 lakh hertz. Bats are the animals, they can detect the ultrasonic sound waves up to 1 lakh hertz. That's quite interesting, no? Let's see. And after that, I want to tell you how many types of waves are there. How many types of waves are there? Let's see. There are 2 types of waves. One is transverse wave and the next one is longitudinal waves. Let's see. Transverse waves. I will make a tabular form so that you can understand easily. Transverse and longitudinal. Get it? See, by definition, the transverse waves, the particles of the medium vibrate perpendicular to the direction of the propagation of the wave. Such a wave is said to be transverse waves. Listen to me carefully once again. See, if the particles of the medium vibrate perpendicular to the direction of the propagation of the wave, then such waves are said to be transverse waves. Let's see. Here I can show you the transverse waves. Here is an apparatus. See. Let assume that this is the source of the energy which are producing the transverse waves. Let's see. See, you can see that the formation of waves. This is called trough. whereas this is called crest. Let's see. This is called crest and the longitudinal waves. For that, there is another apparatus with me. Let's see here. This is a spiral spring. See, I have expanded this. You can see the denser medium which propagates. See, you can see that. Yes, you have said. See, in the picture I can explain you that. This is the spiral spring. See, the denser spiral spring together is called compression, and this looser medium is called rarefaction. Compression, rarefaction. These, whereas in this transverse waves we can get the crest and troughs. Like that, similarly in the longitudinal waves we will get compressions and rarefactions. Due to the presence of compressions, this is also called as compressional waves. Get it, my dear friends? Actually, you all know all this, you are a brilliant children, even though I am saying that. Let's see the second one. You have to differentiate both them so that you can you can get it in your memory. See, distance between two successive crests or troughs is lambda by 2. Then what is the second point here we'll get? Yes, you are right. Let's see. The distance between two successive compressions and rarefactions is lambda by 2. Get it? And the third one, you can see here, every particle executes simple harmonic motion. Naturally, every particle executes simple harmonic motion. Here also. Simple harmonic motion. Let's see. Now you have got the differences between the transverse waves and longitudinal waves. Then see what are the examples. Here the examples of longitudinal transverse waves are light waves and water waves. And for here, sound waves. By seeing the examples, you can know that the longitudinal waves require a medium to propagate. Get it? The longitudinal waves require a medium to propagate, whereas in this, see, these are light waves and these are water waves. Water waves require a medium to propagate. In the name itself, the water is a medium for that waves, and the light, which belongs to the electromagnetic waves, does not require a medium, and they can pass through in the vacuum also. So how they come under the examples of transverse waves having two different properties? Let's see. One crest and trough forms a wave. Basing on this one, light waves and water waves are come under the transverse waves, because in the light waves, in the water waves, we can see the crest and troughs. Get it? And the sound waves. And in the previous I have told you that sound waves are the examples of longitudinal waves which propagates in the form of longitudinal waves that can produce the sensation of hearing on reaching the ear. Now you have got the transverse and longitudinal waves. Let's see what are stationary waves. Before going to that stationary waves, see, here there is a guitar in my hand. See, this string is fixed between two ends. If I make a strike, it vibrates. It vibrates with more oscillations because the thickness is very less. From this you can know that the sound depends. See, the sound depends on the intensity and pitch. See, this is the very thin spring, thin one, and if I strike the bigger one, see, vibrations. This is because it depends on the intensity and pitch. Sorry my dear friends, you have reminded me. Sorry, I forgot to tell you that the distance between the crest and trough is lambda. Sorry, please excuse me, lambda. That means the distance between a crest and trough is lambda, and the distance between compressions and rarefactions is also lambda. This is the compression and this is the rarefaction. The distance between the compressions and rarefactions is also lambda. Sorry, please excuse me. And the next we jump into the stationary waves now. Let's see. Stationary waves. Let's have a glance at this stationary. Actually, this is the content of our topic. This is very important. Make a start. See, by definition, stationary waves. Let's see. The waves which are coming from both the directions with equal amplitude and frequency and superpose. The superposition of two progressive waves results in the formation of stationary waves, or we can call it as standing waves. See. Let us assume that this is one wave coming from a direction. And this is the another wave in the opposite direction. Let's see, this is the one wave, wave 1. Let us assume that this is y1 and this is y2. From here it will travel y2. See, this is the node. This is the antinode. This is called as node because the displacement or amplitude at this node is 0. So we can call it as node. After this I will explain you how it comes. This is the antinode. Where the displacement or amplitude is maximum, then that point is said to be antinode. Let's see. Wave equation. The first progressive wave equation, as it coming from normal direction, see, A sine kx minus omega t. This is the first equation, and the next y2, which is coming from opposite direction, kx plus omega t. Get it? See, these are two waves. The equations of two progressive waves are here. What I told you in the previous class? Yes. See, the combination of two progressive waves, whether it can be transverse or longitudinal, the combination of two progressive waves are equals to the one stationary wave or standing wave. Let's see. That means y is equal to y1 plus y2. Let's prove that. y1 plus y2. Here you can see the video. Let's see, friends. Here is the video. Stationary waves. As I draw here. Yes, you have seen the video now. Now let's derive the equation for one stationary wave. A sine kx minus omega t plus sine kx plus omega t. Friends, you all know this formula, sin c plus sin d. Let's derive. Sin c plus sin d. 2 sine c plus d by 2 and cos c minus d, kx minus omega t minus kx minus omega t by 2 c. This is the formula. Let's get it cancelled. Let's see. A 2 sine 2 kx by 2 and cos 2 omega t by 2, whereas cos of minus theta is cos theta. So we can remove this minus. Now you got C 2a sine kx cos omega t. This is the required combined equation of two progressive waves, which we call as stationary wave equation. Get it? Now let's see how the equation will help us to derive the displacement at the nodes is minimum and the displacement at the antinode is maximum. Let's see. Let's see how it helps us. See, listen to me carefully, this is the very important part. See, actually it is better to draw more so that you can understand. More in the sense 3 I have drawn. Okay, let it be. Let's see. The distance between, this is the node and this is the node. This is the antinode. The distance between the node to an antinode is lambda by 4. Get it? Lambda by 4. The distance between two nodes is lambda by 2. Get it? Then next lambda by 4. Then this, the distance between this first node to second node. Let's calculate lambda by 4 plus lambda by 4, 2 lambda by 4. Then you will get lambda by 2. Here it is lambda by 2. Get it? Are you all of you catching my point now? Let's see. Then here, how much it comes? Yes, lambda by 2. Yes, lambda by 4. See, what we will get? Excuse me friends. Lambda by 4 plus lambda by 2. Lambda plus 2 lambda by 2, lambda by 4. That means we are getting 3 lambda by 4. See, I can clarify your doubt. The distance between one node to antinode is lambda by 4 we have, and the distance between one antinode to node is also lambda by 4. Then node to antinode, lambda by 4. See, 3 lambda by 4 and the resultant is over here. Get it? Clear? And the next, now here we got 3 lambda by 4 plus this one lambda by 4 plus up to this lambda by 4.